we're going to try something new this year and review epidemiologic study designs as an online lecture. The objective of this lecture is to review the various epidemiologic study designs that are available for your use as you design your own study to answer your hypothesis. I hope the lecture is a review of the study designs that you learned in the Intro to Epidemiology course, and we're going to focus on observational studies rather than clinical trials or other experimental designs. What I'm going to do is briefly review all the study designs and then go in depth on ecologic, cross-sectional, cohort, and case control studies. And we'll talk more in depth on the advantages and disadvantages of each of those and briefly review the analytical approach to estimating the associations between your exposures and disease in those studies. Keep in mind that there are a variety of potential study designs available to you, and you'll need to design your study so that your hypothesis and aims are addressed in the best way possible. The conclusions you draw and the strength of those conclusions are dependent upon your choice of study design. The process of designing your study is an art, and it often takes multiple iterations before you reach a final design and protocol. There are often multiple ways to approach a hypothesis, and while multiple designs might seem to be appropriate, there are better ways to conduct epidemiologic studies. Factors you need to consider when coming up with your study design include the availability and type of data that is available to you, both the exposure and the health outcomes. Often, the study population dictates the design, including whether or not you have clinical cases or access to electronic medical records, or maybe you have an existing population from which you can form a cohort. Don't be surprised if your initial thought on the study design changes as you work your way through the rest of the proposal. I would suggest starting to think about your study design by considering your outcome and predictor variables. Recall from a previous lecture that the outcome or dependent variables are those outcomes of interest to you, including health status, disease severity, mortality, etc. The predictor variables or independent variables are those characteristics about the study population that are associated with the outcome. These might include gender, age, exposure, an intervention you did, or other factors that you hypothesize to be associated with your outcome. The best study design is going to collect these variables and allow for the strongest analysis of their association. Let's start by reviewing the basic premise of epidemiology. That is, to study the distribution and determinants of health, disease, or injury in human populations. One way of doing this is to describe the distribution of disease, for example, the prevalence of disease X by person, time, or place. Descriptive epidemiology is often useful as a first step in generating hypotheses or guiding public health actions or establishing baseline data. When we start to turn toward the study of determinants of disease, we're beginning to enter the realm of analytic epidemiology. That is, the study of the causes or risk factors that are associated with disease. Often we further categorize these by the health outcomes of interest or the exposures, for example, cancer epidemiology or cardiovascular epidemiology or environmental epidemiology. So, most epidemiologic research is conducted through observational studies, and that's because frequently experimental randomized clinical trials, for example, are not feasible or ethical to conduct in human populations. So, for example, prenatal alcohol exposure, tobacco smoke exposure, these are exposures to toxicants that we can't randomize to an intervention group or an exposure group and study the difference between those that are and aren't exposed. And so we're left with doing observational studies that are hopefully lead us to the same results that we would get from a clinical trial. So in the realm of observational studies, again, we have descriptive studies and analytic studies. Descriptive studies, again, provide information on the patterns of disease, and these can be correlated with clinical or laboratory observations. But most often, I would argue that descriptive studies are in the realm of hypothesis generating, and that might then lead to another study design. Analytic studies are where we test hypotheses. And so that's where, again, we're going to focus for this lecture, and where we're going to focus and where your studies are going to be focused. This figure is taken from a 2002 Lancet paper and provides a nice overview of distinguishing characteristics of epidemiology or clinical research. Starting at the top of the figure, we can initially categorize studies as experimental or observational based on whether or not the investigator assigned the exposure. If that is the case, then we're talking about experimental studies that can be categorized as random or non-random. If exposures were not assigned, that is, if the study is not a clinical trial, then we're in the land of observational studies. Note the distinguishing characteristic of analytic versus descriptive studies.
Nope.
In descriptive studies, we are not comparing disease or exposure among varying groups, while in analytic studies, we have a control population that we're comparing things to. The three broad categories of study designs under the umbrella of analytic studies vary by their directionality. That is, cohort studies start with exposure and continue prospectively to determine the outcome. Case control studies start with the outcome, i.e. you define your cases and controls up front and then look back for exposure status in the cases and controls. And in cross-sectional studies, we assess exposure and outcome simultaneously.
He has to come.